Hi, this time I'm going to teach you how to sketch rational function. Okay? And given that function 1 over ax plus b is linear, so the function is fx is equal to 1 over x or negative 1 over x. For this function, okay, 1 over x, the graph is inside the first quadrant and the third quadrant. So it has the asymptote. So the graph never touch at y-axis, and this is also asymptote and asymptote. It's graph for 1 over x. And then for the graph negative 1 over x, okay, the graph is in the second and fourth quadrant. It's negative. Get the value. You can choose one value. Let's say this is 3. So 3 substitute negative 1 over 3. So y is negative 1 over 3. So here. So the graph is lies in the second and fourth quadrant. The general form for the rational function. Okay. For the first example, given that function fx is equal to 1 over x minus 3. First thing, try to find domain. Domain for this rational function, the denominator cannot equals 0. The denominator cannot equals 0. X minus 3 not equal to 0. Means x not equal to 3. The domain of f is all real numbers except 3. Or we can change to number line. Okay, this 3. The domain is all real numbers except 3. Negative infinity up to 3. Negative infinity up to 3. Union 3 to infinity. This is domain for this function. Okay. Then this is actually for the rational function. The graph has asymptote. So x not equal to 3 means x equals 3. Consider the vertical asymptote. Vertical asymptote. Then we're going to find the horizontal asymptote. To find the horizontal asymptote, here actually by observation you know y is equal to 0. But we try to prove properly. Okay, write x as a subject. Here. Then the denominator y cannot equals 0. Or we can conclude that the horizontal asymptote is y is equal to 0. Vertical x is equal to 3. Okay. And now we're going to sketch. Okay. So this graph horizontal y is equal to 0. Then the vertical is x is equal to 3. Vertical asymptote. This is called horizontal asymptote. The graph never touch the asymptote. Okay. Then we're going to sketch it. The graph is either lies in the first quadrant, third quadrant, fourth quadrant, or skip. Okay, something like skip up and down. Okay. Then sketch the graph. Okay, the graph is say like 1 over x or lies in the first and third quadrant. Okay, take one number here. The graph is here. And the third quadrant. You can check what happened when x is equal to 0. Substitute when x is equal to 0. 1 over 0 minus 3. So the graph intersect. Okay, y-axis x at 1 over negative 3. Negative 1 over 3. So 0, negative 1 over 3. The graph is asymptote. Okay, intersect at y-axis and sliding down. Okay, you can check one value. Choose one value. Let's say this is 4. Substitute 4. Okay, y equals 1 over 4 minus 3 and 1. 1, let's say here. So this is correct graph. And at the same time, choose, let's say, this is negative 1. Substitute negative 1, negative 1, negative 3. So, negative 1 over 4. Say negative. So, this graph is, okay, settle. This one is, the graph is right graph. Okay. So, to find the domain, this is called domain. Then we're going to find range. Okay, from the graph, it shows that range consider y value. Okay, from bottom up to here, stop. Then from 0 up till infinity. So we can conclude that the range is from negative. Okay, the range from negative infinity to 0, union 0 to infinity. Range. Then this one is domain. Settle for this example. Okay. Let's say the same function but with restricted domain. X more or equal 4. The domain for this one still all real numbers except 3. All real numbers except 3. This is domain for this function. But the given question is restricted to x more or equal 0. Means we need to consider the domain from 4 to infinity. So now the new domain is from 4 to infinity. Means that no graph on the left hand side. The graph only in the green region. Okay, we're going to sketch the graph, but this is a rational function. We should have vertical asymptote and horizontal asymptote. Vertical asymptote x not equal to 3, so vertical is x equal to 3, and horizontal asymptote is y is equal to 0. Same like the previous example, y is equal to 0. This is horizontal asymptote. Vertical asymptote here, so not included in the new domain. Okay, just consider the green region. And to find the sketch graph, we just substitute into the formula, the function. Okay, and then 1 over 4 minus 3 is equal to 1. So when x is equal to 4, the graph y is equal to 1. This is just 1 point included. Then what happened when let's say just choose one number here. There is 8 or something. Choose one number. 8. Let's say 8. So substitute 8. Okay, y is equal to 1 over 8 minus 3, 1 over 5. 1 over 5 is 0.2. 0.2 is less than 1. So the graph is sliding down here until this is got a asymptote. So the graph is approaches x-axis but never touch x-axis. Graph. Okay. Now going to find the domain. Domain is given. Domain is 4 to infinity, and range. Range of the graph is from here, from 0 not included up to 1 included. So from 0 to 1 included. This is range for this function. Okay, for this function, 1 over 3 minus x plus 1. Domain still denominator not equal to 0, and domain is all real numbers except 3. Okay, then domain from negative infinity to 3, union 3 to infinity. So domain. Okay, now here, because this is rational, okay, the graph should be have a vertical asymptote, that is x equals 3, and horizontal asymptote. From the observation, you can see that horizontal asymptote is y equals 1, but we need to show properly. Write x as a subject, and then you get y is equal to 1. Is a horizontal asymptote. This is y equals 1, horizontal asymptote, and this is vertical asymptote. Okay, we're going to sketch the graph. the graph is 1 over minus x. So when 1 over minus x, the graph is in the second and fourth quadrant. Okay, second and fourth quadrant. So 1 over negative. Negative. So just take few value and substitute. Okay, let's say choose value is 3. Just okay, when x is equal to 0, y is equal to 1 over 3 plus 1, positive. That is 4 over 3. 4 over 3 is more than 1. Something like here. Okay, the graph intercept y-axis at 4 over 3. Okay, and the next step, just choose one number here. Negative 1. Negative 1. So 1 over 3 minus 1 over 4 should be also positive. Okay, but less than, okay, when x equals negative 1, y is equal to 1 over 4 plus 1 or 5 over 4. Okay, find in decimal, 5 over 4 should be less than 4 over 3. Okay, so we can sketch the graph is this. Okay, and this is asymptote. Okay, the graph is lies in the second quadrant. This is asymptote, horizontal, and this is vertical, asymptote. You try to the second graph, which lies in the fourth quadrant. Okay, choose one number. Let's say here is 4. Okay, when x is equal to 4, and then just substitute y equals 1 over 3 minus 4. Okay, negative 1 plus 1, 0. So 4, 0. This is the point. That means it intersect at 4 at x-axis. Okay, and the graph is something like this. Okay, you can check and choose one value. Let's say 10. When x is equal to 10, substitute 1 over 3 minus 10, negative 1 over negative 7 plus 1. And then get 1 positive. 1 over negative 7 plus 1 answer is. Let's say you can choose something like 3.5. 3.5. 1 minus 0.5 means that 2 plus 1. 1 over 0. 1 over 3 minus 3.5. Okay, show you. Let's say just choose one value here. 3.5. 1 over 3 minus 3.5 plus 1. This is negative 1 over 0.5 means that negative 2 plus 1, and I get negative answer. So negative answer. So this is the graph, which lies in the second quadrant and fourth quadrant. Now we're going to find the range. Range of f. Okay. For range, set a value y value from bottom up to 1 stop and 1 up to infinity. So the range is from negative infinity to 1 union 1 to infinity. Okay, that's it for how to sketch rational function.